Okay, good morning, everybody. Let me just first use this opportunity to thank the folks at CARPHA and the organizers for giving me the opportunity to present at this forum. Special thanks to Dr. Kristen Fredrickson. This morning, I'm here in the capacity of a medical entomologist and parasitologist attached to Ministry of Health, specifically Insect Vector Control Division. Right? My presentation this morning will be on a field evaluation of the In2Care semi-lethal OV trap for the control of Aedes aegypti mosquitoes in Trinidad and Tobago. And I hope you all are very excited to hear about this new trap. If you're not, hopefully you will be at the end. So, just a little background on Insect Vector Control Division before I start. At the Insect Vector Control Division, we've, for the most part, been doing the same thing for many, many years. For the last 30 or so years, the process for vector control, strategy for vector control have been more or less the same. And I'll tell you what that strategy is. We have a very large workforce of maybe about 700 or so workers. Out of that, maybe 400 to 500 or so field workers. We have workers in every county. We have perifocal operators, health control officers, charge hands, malaria evaluators, field evaluators, right? And we have public health inspectors at the higher level. Now, the strategy has been that we operate in cycles to cover every area in Trinidad. Right? When we go out to an area, what we do first is perifocal work. So we have the perifocal operators go out there, do inspections, work with the community, work with the residents, get them to clean up the surroundings. Right? We use larvicide if we find breeding. It's recorded. All of this work is recorded, so we have data on all of this for many years. After which, we go in and do fogging, right? Either through thermal fogging or ULV application. The chemical that we use is malathion, right? 96.5% ULV grade. We also use the malathion in the thermal foggers at WHO recommended specifications. So this is generally what we do. After fogging, we send the team back in to do residual spraying. So we use chemicals such as alpha-cypermethrin or propoxyl to spray the walls around the houses. Now, this strategy for the most part have proven well, and we think that using this approach, we were actually able to slow down the attack rate for chickpea in Trinidad. But we constantly on the lookout for new strategies and new techniques to implement. And I started here very recently, and when I started, we introduced things like the In2Care semi-lethal OV trap. We introduced aquatine, PTI. We're also in discussions with Oxitec for use of genetically modified mosquitoes. So we're having discussion on many, many different areas and new techniques, new approaches to vector control. Okay? So this morning I'll focus the presentation then on one of those initiatives, which is the In2Care semi-lethal OV trap. And you'll understand why it's called a semi-lethal OV trap in just a bit. Now, this In2Care is a foundation in the Netherlands. It's a company in the Netherlands, and the In2Care semi-lethal OV trap was developed using a grant from the Bill and Melinda Gates Foundation. Right? It makes use of several key entomological principles when it comes to Aedes aegypti mosquitoes. So we look at the biology. They looked at the biology of the Aedes aegypti mosquito. It's day active. It's attracted to containers, specifically black containers, right? Dark containers. And it's a skip ovipositor. So the gravid female doesn't lay her eggs all in one place. She lays a few, goes to another site, lays a few, and she continues that process. So the folks at In2Care came up with a brilliant design. Looking at traditional approaches where we would do adulticidin separately to larvicidin, they decided, why not combine both? Why not have a trap that can target both the adults and the larvae at the same time? So they also wanted to do something that is environmentally friendly. So they decided to use bioactives then in the trap rather than traditional harsh chemicals. So it's more environmentally friendly. One of the other selling points of the trap, and if I show you the trap, this is the OT trap. It looks like a flower pot, doesn't it? Because it is. It's essentially a flower pot. In the Netherlands, this bottom part, the base, is what's used to plant flowers, right? So they would use it around the house. So they modify then the flower pot, and on the video, just a lid, just a cover. There are several principles, which went scientific principles and scientific testing that went into the design of the trap. But this is just to put it in perspective as to the actual size of these things. So it's made of durable polyethylene components, it's plastic. It holds about 3.5 liters of water. Maintenance, importantly, is needed every about 6 to 8 weeks. And all maintenance involves is opening one of these sachets and replacing the gauze with the chemicals, with the bioactives, inside the trap. Now it's a very low-cost solution because it's made of plastics. The cost of one of these traps is just a couple hundred to 300 or so TT. So what happens? It attracts the Aedes aegypti mosquito into the trap because of the bioactives in the trap. The mosquito gets contaminated with 2 bioactives. One is a larvicide and the other is a fungus. She lays her eggs inside the trap and she flies out. So the scientific principle that we're making use of here is auto-dissemination, because she picks up some of the larvicide from the trap and she transfers it then to other sites, because we're making use of that skip oviposition principle. She transports it then to other breeding sites with breeding locations. But she would have also picked up some of the fungus spores. Now that fungus is Beauveria bassiana, and Dr. Marit Farnhouse from In2Care has done her entire PhD thesis work on Beauveria bassiana. The fungus, there are fungus spores in the trap. The fungus attaches to the cuticle of the mosquito, grows through the cuticle, releases toxins, and that does 2 things. It slows down virus replication, or stops virus replication within the mosquito. Scott might be interested in some of that research. And it also kills the mosquito eventually. Right? So, as I said, the bioactives are Beauveria bassiana, which are fungal spores, which is 10% weight by weight. Pyriproxyfen is the larvicide that's used in the trap, and this is in powder form, 75% weight by weight. Now, that IGR, what it does is to target the larvae, but it targets the larvae because it's an insect growth regulator. You'll often open an In2Care trap and see larvae happily swimming around in there, because it targets the larvae at the late stage, at the L3 to L4 stage, right? And from our experiences in the field, we've noticed a lot of dead L4 and pupae in the trap. Bringing those things back to the lab, we notice the morphological deformations in the morphology, right? So let me see if I can get this video to play, and I will do the voiceover on the video for you so that you have an idea of what's happening. So this is the In2Care trap. It's a nice animation that they provided. So it comes in these pieces. The central piece that you saw there locks in. And this is actually an overflow valve, so that if the water level gets too high in the trap through rainfall, the excess water can flow out through the bottom of the trap. So you fill it with 3 liters of water. This is the floater and the gauze that goes on the trap. Now the gauze is dusted with the larvicide and the fungal spores. The idea with the floater is that it floats on it allows the gauze to float on the water and remain dry and move up and down as the water level changes. The other larvicide and fungus are also added into the trap together with the yeast tablet. And the yeast tablet acts as an attractant to help lure the mosquito, the female mosquito, into the trap. Placement is often important because we need the trap. You need to place the trap in a place that's cool, damp, dark. Right, so here's the female coming in. So grab it, female. So she lands on the gauze, and as she lands on the gauze, she gets dusted with the fungal spores and the larvicide. And here she's laying the eggs, and the gauze. There's science behind this as well. The gauze is actually carries an electrostatic charge. So it actively discharges the fungal spores and the larvicide in powder form onto the body of the mosquito, the female mosquito. So these colors here represent the fungus and the larvicide. The larvae that hatch out into the water here, as there are more and more larvae in the water, you get pheromones being produced, so it also lures more and more female mosquitoes into the trap. So that helps act as an attractant as well. So they die at the pupa stage. By the L3, L4 stage into pupae, they would have ingested enough pyriproxyfen that it affects the morphology such that they're not able to further develop. Right, so the mosquito then leaves the trap, and here she's flying and looking for some other sites in order to lay her eggs. So she searches, she finds an old car tire filled with some water. She lays the eggs in there, and then by doing this, she's transferring the larvicide, right, the pyriproxyfen, into those other sites. So here's another can with water. Now the dosage of pyriproxyfen needed here is less than 10 parts per billion to be effective against those mosquito larvae. Right? So all she needs is a very small amount of pyriproxyfen in these alternate breeding sites in order to kill the larvae. Right, now the range for one of these traps is about 400 meters squared. So one trap will cover that area. So you can work, if you work at the square footage of the area you need covered, then this is the fungus pulse here, and you see fungus growing through the cuticle in the mosquito. Right, so the fungus pores attached, the fungus begins to grow, and then as it grows in, it releases toxins in the body of the mosquito, and those toxins prevent viral replication, but it also kills the mosquitoes in about 8 to 10 days. So it's called, that's why we call it a semi-lethal ovitrap, because initially the mosquito is allowed to leave the ovitrap, right? And we needed to do that because we're making use of the auto-dissemination principle. Right? So in Trinidad, we are in the process of testing the In2Care semi-lethal OV trap. There were two sites that we chose. The intervention site is in the Madras community area, and the control site is in the Las Lomas area. Now, we did a sensitization effort early on in November to get the residents on board, and this is the Madras study site, this is the Las Lomas community. I only have 1 minute, so I'm trying to rush through first. Right, this is it in perspective. Okay. This is it in perspective here. So this is Carney Swamp. This is around where the airport is. So this is the study site, and this is the control area. So what we did is that we put out 200 In2Care traps in the study area, and we are monitoring then the egg counts. We did some baseline monitoring 2 weeks before deployment of these In2Care traps using standard paper paddle OV traps to get an idea of what the Aedes population was like before we deployed the In2Care traps. Now those paper paddles remain throughout the course of the study, and we collect them on a weekly basis to see what the egg counts are, to give us some absolute numbers of if the egg counts are coming down or not. In order to measure auto-dissemination of the chemicals inside of the OV trap, we put out some auto-dissemination trap, both in the control site and in the intervention site. Any pupae found in the auto-dissemination traps are brought back to the lab and are given optimum conditions to check to see if they emerge or not emerge. Right? So we use that as a proxy for whether there's pyroproxyfen present in the auto-dissemination trap or not. And this is the coverage that we had in the control site. Yellow is the number of traps. We had 2 traps per house. We have this auto-dissemination traps, which are red, and sentinel traps, which are shown in blue. So here are the results. All 200 In2Care traps have recorded significant breeding with eggs on the cores and larvae in the water. This gives us an idea of the attractiveness of the In2Care trap. It's very attractive to the mosquitoes. In terms of functioning, the field observations have noted that most larvae do not develop past stage 4. Larvae that actually develop past into pupae do not emerge. We find a lot of dead larvae and pupae then at the bottom of these In2Care traps every week as we inspect. Right? All pupae collected from auto-dissemination traps, AD traps in the treatment site, had a 100% mortality in the lab. All pupae collected from the control auto-dissemination traps, those were in the Las Lomas control site, had a 90% emergence in the lab. Right? So about 3 weeks after the In2Care deployment, absolute egg counts are showing a steady and sustained reduction in numbers, and many of the sentinel traps, OV traps, are already down to 0 egg count. Thank you very much.